configuration, it should contain 8 electrons. Okay, so in order to get 8 electrons, it should get 4 more electrons, so the combining capacity is 4 over here. Okay, now you see that because it is just a small, it is relatively a very small atom and it holds all the electrons. The nucleus holds its electrons very firmly, very strongly. So these 4 electrons cannot be lost, children. Okay, these 4 electrons are held by strong forces by the nucleus. It's relatively a smaller atom. It always forms covalent bonds. Now the thing that you have to know here is that why is it forming only covalent bonds? Covalent bonds means it is sharing of electrons. Sharing of electrons. Do you think that, can you imagine that it can give away all the 4 electrons or can it gain 4 electrons? Let us see the first case now. It cannot give away these electrons because it has only 4 electrons and all these 4 electrons are very tightly held by the nucleus. It requires a lot of energy to actually give away. It won't. And if it wants to get 4 electrons so that it gets in a gas configuration, it cannot get 4 electrons because the atom is relatively small and because of the energy considerations, we cannot say that it cannot take 4 more electrons. So it always tends to share electrons here. If any bond is formed by sharing of electrons, it is called as covalent bond. Okay. So let us see why carbon always forms covalent bonds. It cannot form ionic bonds. So let us see that depends on its electronic configuration. The electronic configuration is 2 and 4 because there are 6 electrons here. In order to obtain the inert gas configuration, it should get to 8, which is that of a neon, right? So in order to get this, it should get 4 more electrons, right children? So it cannot take away 4 electrons by forming an ionic bond because it's relatively a smaller atom. It's relatively a smaller atom which contains 2 electrons in the first shell and 4 electrons in the second shell. It cannot accommodate 4 more electrons in the second shell because it is relatively a smaller atom. So what is the other way? It cannot lose all the 4 electrons out also because these electrons are held strongly by the nucleus, children. They are held strongly by the nucleus. So it's difficult to remove all the 4 electrons also. So the only option left is nothing but sharing of electrons. So it shares 4 electrons. That's why the valency becomes 4. Sharing means it is a covalent bond, children. So always carbon forms a covalent bond. Okay. So it is represented like this, children, of the 4 valencies. The valency of carbon 4 is represented by 4 bars like this so that it can form a single bond. 4 single bonds it can form with different atoms. Okay, like A, B, C, D or X, Y, Z. So it can be different compounds or atoms or radicals, or it can be same also. It can be A also. So depending on the changes, depending on the different groups that are attached to the carbon forms different, it combines with different atoms and form different compounds, and that is the reason why it is so much abundant in nature. You can see that the next one that I am going to speak about is catenation. Catenation means self-linking, children. That means carbon and carbon together can form self-linking with the help of covalent bond and form long chains of carbon backbone. Say for example, carbon and carbon linkages like this, children. Carbon can form bonds with the other carbon atoms and form long chains, or it can also form temperature.